Hello everybody, I hope you're doing well today. We're going to continue our look at question number 5 on the Intermediate Math Contest, the Canadian Intermediate Math Contest from 2016. So question 5A on the contest. It also happens to be the 5th question. Let's take a look. Now we just need to keep in mind we don't need to actually justify things. However, we're going to go through it and write up a little bit and explain, or at least I'm going to explain what's going on. So question 5 looks a little wordy. It's got a nice circle picture here. In the diagram, P and Q start at the positions shown, and point X is fixed on the circle. So P and Q, I'm guessing from the arrows and the language, start at the positions. P and Q will move, so we maybe think of them as like people running, like Pierre and Quentin, or Polly and Quinn. I don't know, but it looks like they're going to be running around a circle. P will go this way, Q will go this way, but X is not a runner. X is some fixed point, like the start line or the refreshment stand or something. I don't know. So X is fixed on the circle. Initially, the shortest distance along the circumference from P to X is 8, as shown, and the shortest distance from Q to X is 16 meters. And from P to Q is 16 meters. Okay. P and Q move around the circle in opposite directions, as indicated by the arrow. P moves at 3 meters per second. Q moves at 5 meters per second. If P and Q begin moving at the same time, after how many seconds do P and Q meet at X for the second time? Ooh, okay. So, there isn't that much of a change in their, or that much of a difference in their speeds. How many seconds do P and Q meet at X for the second time? So, they're both running sort of at each other in the general direction of X, so they're going to meet at some point. I don't think they're going to meet at X on their first meeting. They'll probably meet at X at another point around here. So, one thing to note, I guess, might be, I might need this later, circumference of the circle is 8 plus 16 plus another 16. That's 5/8. That's 40 meters. Okay. So what I want to do is I want to find their first intersection. X is here. I'm guessing that they'll probably actually, because P moves faster than Q, right? No, Q moves a little faster than P, but P has a much shorter distance to X. So I imagine their first meeting will probably be somewhere around here. Okay, so if that's their first meeting, then we can from there, like knowing that they're at the same place, wherever that is, and we'll work that out. The one guy's going 3 this way, and the next guy's going 3.5 this way. Knowing that they have to make up 40 meters together, we can actually then figure out where their next meeting is. And then from there, their next meeting, and it'll bounce around. Eventually, it's going to land on X. Okay. So what I'm imagining, although this is greatly simplified, is I'm imagining something like, they meet here, and then the next time they meet is 5 meters clockwise from there, and then 5 meters again, because once we know the distance from one meeting to the next meeting, it's going to be the exact same. It's just going to be sort of rotated. So eventually we'll be able to predict when we plop onto X for the first time. And then from there, it's just, well, how many of these cycles do I have to repeat to get back to X? To get our meeting place to shift back to X, because it sort of shifts by a certain amount each time. So that's a greatly simplified idea behind how I'm thinking through this problem. So the first thing I want to do is figure out where they meet for the first time. So X is here, we've got 8, we've got 16. Q is rushing this way, P is rushing this way. So together They are moving closer together at a combined speed of 3 plus 3.5, or 6.5. 6.5 meters per second. The way somebody recently tried to explain this concept to me, because I was looking for other ways to try and explain it to you guys, is we've all been in a car, or at least I hope we've all been in a car or on a bike or some other thing, and we've seen someone else. So we're driving in our car, we're sitting in the back seat, or we're pedaling our bike, and someone else comes, and they're coming this way. Now I'm going at, say I'm on a bike, I'm going at 5 meters per second. They're also going at 5 meters per second, and yet it appears they're coming really fast at me. Because if I imagine myself as stationary, it looks like they're actually approaching me at sort of 10 meters per second, because they sort of add. And that's the same sort of idea. We're getting closer to each other. Like I'm moving a certain amount, he's moving a certain amount. We're getting closer to each other at a combined amount. Just like if I'm going and someone else is going the same direction and they're going a little faster than me, they're going to pass me, but they're not going to pass me at, like if I'm going at 5 meters per second and they're going at 6 meters per second. As they pass me, it won't seem like they're going at 6 meters per second. They're only gaining a meter per second on me. Because that's if we're going the same direction, then it's the difference, is how fast it appears that he's catching up on me. Okay, so that's sort of an analogy that most people, everyone's been in motion, so most people should be able to get that one. So there's another explanation for you as to why we add these two velocities. Okay, so they meet. I don't know where they meet yet, but they meet after, well, they need to have gone a total of 24 meters. And how long does it take them to go these 24 meters if they're moving at 6.5 meters per second? So 6.5, so 24 meters, and 6.5 is the same as 13 over 2. This will just make it easier for our calculating. So this will be 48 over 13 seconds. That's how long it takes them to meet. And where do they meet? They meet at, well, P has gone 3 meters per second in this amount of time. So they meet at 3 meters per second times 48 over 13 seconds. So they meet at 48 times 3 is, carry the 4 and the 2, is 144 over 13 meters from P. And where is this relative to X? So this is around 11.07 meters. So X is at 8, so we're a little bit further. We're at 11.07 meters. So we're not quite at X when we first meet, but there's where they first meet. Okay. So where do they next meet? After they've met the first time, then they're really at the same place. Okay, P and Q as runners, they're both here, and X is still up here. So Q is going to keep running, and so is P. And if we sort of cut it right here and unfold it, it seems like Q is running at 3.5 meters per second. P is running at 3 meters per second. But now they have to make up a full 40 meters. Okay? Where do they meet after that point? And P is the one who we're going to keep measuring things by. So P is running clockwise. So we'll find that, oh, they meet here, which is X, or not use X, let's say D meters. So it'll be D meters clockwise that they meet again, and then D meters clockwise from there, and so on. Okay? So, how long does it take for them to meet again? Because remember, ultimately they're asking how long until they meet at X the second time. So this might be somewhat crucial information. Is something that we need to know is how long does it take them to meet each time? So it takes 40 meters over 13 over 2 meters per second, 80 over 13 seconds to meet again. And they meet 3 meters per second times 80 over 13 seconds, or 240 over 13 meters clockwise from their previous meeting place. Okay. So, what do I do with this information? So, let's draw a big circle. And up here we're going to place P. This is P's starting location. And then we got our good buddy X. He's 8 meters, but I'm going to change that to 8 times 13. So 104 over 13 meters. Just because I'm noticing everything I'm doing has a denominator of 13. So I might as well get things in terms of 13 on the bottom. And if everything has 13 on the bottom, then I can add and subtract and not really care about that 13 on the bottom. Okay, that's the idea. So they first meet, oh gee, what did I say? They first meet 144 over 13, so 40 13ths of a meter more. So this is our first meet. So in between we got 40 over 13 meters, so 144 over 13. Then our next meeting occurs 240 over 13 meters from there. Okay. Then our next meeting occurs 240 over 13 meters from there. And it's going to keep going around and around. How many meters are there in total? Well, there's 40 meters, but that's really 520 meters over 13. Okay. And we want to get to 104 over 13. So we got 100. So over here, first meeting, 144 over 13. Then we're going to go 240. So 144, and then add on 240 to that. So we're going to get 384 over 13 meters. And then we're going to get 6. So basically add on 240 each time. So the 4 will stay there, and that's how we can get 104 eventually. But it'll be 624 over 13 meters. But once we've gone 520 meters, that's the same. Once every 520, we're back at P. So this is really the same as 104 over 13 meters from P. And so this is the first time they meet at X. So they meet once, then they meet again, then they meet for the third time, and that's when they first meet at X. And we can figure out times, but we're not done yet, because they want the second meeting. The second time we meet at X. Okay. Well, we know when they meet at X the first time. Now let's ask, how many times does it take for them to come all the way back to X? That'll be their second meeting at X. And then we can go ahead and start calculating. Well, it took this many meetings and each meeting has a time interval of blah between them, so we'll add up this many, and don't forget how much time it took them to do their first meeting, so we'll add that on. But we first have to say, well, how many times do they meet before they meet a second time at X? Okay. So it looks like after every 2 meetings, we go back by 40 meters. So every other meeting, maybe? Every other meeting takes place 40 over 13 meters before it. So we met, second meeting, and then third meeting was here at X, 40 meters before. So we'll meet a 4th time, and then we'll meet again 40 over 13 meters before X. And then that'll keep happening. Well, 40 over 13 takes 13 every other meetings. To go around the 40 meters of the circle. So it'll be 26 meetings after this meeting at X that we come back to X. So every 26 meetings after the third meeting, we are at X again. So we meet at X at the third meeting, and then finally we meet at X at the 29th meeting. So this is our second time at X. Okay. So, how much time does it take for their first meeting, and then how much time for the 28 meetings in between there? So we worked out our first meeting. Takes place 48 over 13 seconds. And then every other meeting after that is 80 over 13 seconds. So there's 48 over 13 seconds here, and then 28 times each of the 80 over 13 seconds between meetings. So everything's over 13, like I've said. So 48 plus 28 times 80. And I'm pretty sure calculators are allowed on this contest. I can never remember. I did use a calculator a second ago, but calculators are allowed for numerical calculation, so good. So I'm just going to pop out my calculator. 28 times 80 plus 48. I get 2,288 over 13 seconds. Until they meet at X for a second time. Okay, so I sort of have been skimming over things. I want to just go back and double check and make sure it all makes sense in my head. Okay, so our first meeting, yes, the 6.5, that's clear, because otherwise that'd be annoying and messy. 13 over 2, so yes, 48 over 13, so that's till first meeting. And then the time till the second meeting, that's 2 minus 1 meetings between that, should be then 80 over 13. Okay. So that's all clear, and it takes 240 over 13 So I just want to make sure every 26 meetings, do we go back to the same place? So 26, and we go 240 over 13 each time. So that'd be 2 times 240 meters. So that'd be 480 meters. And that is a multiple of 40 meters. Is that the smallest multiple of 40 meters here? Well, to get a multiple of 40 meters in an integer amount of time, we would need n times 240 to be 13 times 40. Some multiple of 40, so we'll add a k on here. But 13 divides this side, 13's got to divide this side. 13 doesn't divide 240, so 13 has to divide n. So 13n would be the smallest we could do. But if you do that, then you'll get 13 times 240, and that'll be, 6 times k. So why isn't that us meeting again? So yeah, I think it's every 13 meetings. I'm glad I went back and processed that again. 13 meetings. After 13 meetings, if I go 13, 240 over 13, that will be 6 times around the circle in total I have moved. So I'll be back where I'm starting. So every 13 meetings after the third, we are at X again. So it's not the 29th meeting, it's the 16th meeting. I do apologize. This is why we double check. So it'll be, I shouldn't have put that tacky X all the way through all that work. I was just excited. So not 16, it'll be 15. So 16th meeting, 15 meetings in between these. So it'll be 15 times 80. And that's a much nicer number to compute. So it'll be 15 times 80. That's 1200 plus 48. So 1248 over 13 seconds. And there's no way that's divisible by 13, right? Oh, it is. It's 96. That's interesting, but a little coincidental. So 96 seconds. I wonder if there's a way to view that without all these pesky 13s. But after 96 seconds, they will meet at X for the second time. Okay. So I think that's it. Let's just clear the logic again. I'm fine with the number of meetings. And if it's from 1st to 16th meeting, then yeah, that's 15 times in between. So that's all clear as long as it's the 16th meeting. So if 26 times 240 over 13 meters is some multiple of 40 meters, i.e. some multiple of times around the circle, we need 13 divides the one side, so 13 has to divide n. Taking n as 13 has got to be the smallest. And that does give us an integer value for k of 6. So yeah, that all works out. Okay. So 96 seconds, I almost got the wrong answer. I almost put too much, but having even just the little bit that I did right wouldn't have been so bad, and I probably would have gotten maybe 2, hopefully 3 on that one, had I just left it where it is. But I stopped, I double-checked my work, I double-checked my thought process, and there it is. So that's my answer to 5. I'm nervous to move on. I want to double-check it more and more, because I don't like screwing up on video, because it's stuck here forever. But we're going to move on to A6, the last question in part A. So join me for that in the next video, and I'll see you guys there.